So today we are going to see memory designing, or it is also called memory interfacing. This is your microprocessor, this is your memory. You want to connect this memory with your microprocessor. This is called memory interfacing. So what you are doing in memory designing or interfacing, you want to, like, there may be multiple chips of memory. There are 10 chips and you want to access that 10 chips. Each chip will have different address. Understand? So if I want to store something into this XYZ chip, it should go to that XYZ chip only. So I should know the address of that XYZ chip, starting address and ending address. Understand? So how to select out of these 10 chips? I want to select this XYZ chip and I want to store something on that particular location on XYZ chip. How to do that? How I can find out the address? How I can select this XYZ chip only? This is what you are going to learn in this example. Understand? This is called memory interfacing. You want to connect different chips of memory at the same time. You want to access that particular chip and you want to know what is the starting address and ending address of that particular chip. This is what your memory interfacing is. That is clear? What is memory interfacing? You want to connect memories. Now memories can be of two types. It can be RAM, it can be ROM. Random access memory, read-only memory. As the name suggests, read-only memory can only be used for reading purpose. Yes, so there are only read signal, no write signal inside your ROM. In RAM you will have both things, read signal as well as write signal. Yes, that is simple. Now in 8086 we are having total 1 MB of memory. Why we have 1 MB of memory? Because we are having 20-bit address bus. Yes, because of 20-bit address bus we have 2 raised to 20 locations, that is 1 million location. Each location in 8086 can store 8 bit of data. That's why we are having 1 MB of memory. This was already covered just for the revision purpose. Now there is something called reset vector. Okay, in 8086 the reset vector is stored on location FFFF0. Here your reset vector is stored. What is reset vector? It is same like BIOS. When you start your computer, first BIOS will come up, then it will load the operating system and everything. So there is a starting point. That is your read-only memory, there where ROM is used. Yes, from where your main program gets loaded, once the OS gets loaded, then you are using your RAM and everything and you are doing all the operations. તમારું PC ચાલુ થાય એટલે પહેલા ઓપરેટિંગ સિસ્ટમ લોડ થાય પછી તમે કામ કરો જે બી કરો તે ઓપરેટિંગ સિસ્ટમ લોડ સમય થાય BIOS. That is your read-only memory. You understand? So same way in 8086 your reset vector initial point is this. So what do you mean by that? In 8086 by default ROM part will be stored in the bottom. RAM part always starts from the first location. So RAM is on upper part, ROM is on bottom part. This is what you need to know. Yes. Where my RAM started in 8086? Starting location. Where my ROM starts, we don't know. But where it ends, last location. Understand? So, if this is my memory of 8086, what is my starting address? 50H. X. Right? 20-bit number. What is my last location? 5 times F. H. This is my last location. Clear? Yes. RAM stored on upper part, ROM stored on lower part. Clear? Okay, this is what you need to know. Now, how the example will come? How the sum will come in example? You want to do the interfacing of 16 KB chip of EEPROM. You want to make total 32 KB of memory. And using 32 KB of chip, you want to make a memory of 128 KB RAM. Now do the interfacing of this chip. This is what the sum is. It will look like this. समझ पड़ी? તમારે ટોટલ કેટલી મેમરી બનાવવાની છે તે આપેલું હશે, તમારે કઈ ચિપ યુઝ કરવાની છે તે આપેલું હશે. Now do memory interfacing. This is what they ask. Clear? Done? So this is my problem definition. Now I want to solve this example. Okay? Stop. Okay. So now to solve this problem, what we actually want to do, we want to attach this chip with my microprocessor and I want to access the data. This is what my task is. Yes? Clear? Pause. Done? Okay. So to solve this problem, we simply follow some of the steps, and by following that steps you know that what is the starting address of each chip, what will be the ending address of each chip, and how you can access that particular chip to store some data or to read the data. Clear? Yes? Okay. So let's start with step 1. How many chips will be needed? This is what we have to solve. How many chips will be needed? Okay. So you want to make 32 KB of memory out of 16 KB chip. So you require how many chip? 2 EEPROM chip will be needed to make 32 KB of memory. Understand? મારી ચિપની સાઈઝ 16 KB છે, મારે 32 KB બનાવવાની છે, તો બે ચિપ જોઈએ. It is as simple as that. I want to make a 128 KB of RAM out of 32 KB chip. 32 4s are 128. So I require 4 chip of RAM and 2 chip of EEPROM. Understand? Get it? This is your step number 1. This number must be even always. Just keep in mind. So if you are getting some odd number, here itself your sum is wrong. Understand? Why it is even? Because we have already studied memory banking concept in 8086. You are having odd bank, even bank. So there will be 2 banks. Understand? Always. So whatever number you are getting, that must be even. Then only you can have odd bank and even bank. Understand? Yes. So this answer must be even answer. Clear? So here I am having 2 chip, one will be odd, one will be even. Here I am having 4 chip, 2 odd chip, 2 even chip. Understand? This is your step number 1. Now step number 2. What is the step number 2? You need to find out the starting address and ending address of all chips. Okay? What I want to find out? Starting address and ending address of chip. Okay. What is the starting address of RAM? That we already know. What is the starting address of RAM? It always started with this. Yes? What is the ending address of RAM? This is what I want to find it out. Understand? So if this is my location, here my RAM started, where my 32 KB, RAM is 128 KB. So where my 128 KB will get solved. Understand? Yes, this is what I want to know. So what will be the ending address of my RAM? So right now, if you don't find it out, still it will work. So let's keep it that we can directly get it there also, right? You can do it here also, but let's keep it for later part. First of all, find out the starting address of ROM because it is a little bit twisted. What I want to do? Starting address of ROM. Now in case of ROM, what we know, ROM will be entered over here. All F H. So from here, you want to go up 32 KB. That will be your starting location. Understand? Yes. So what I need to do is to get the starting address of ROM, I need to simply subtract F minus 32 KB. Whatever I will get, that is my starting address. Yes. Now I can't subtract 32 KB from this. I need a number which represents 32 KB. How to find out the number which represents 32 KB? Concentrate. 32 KB is equal to 2 raised to 5, 32 into 2 raised to 10 K, 2 raised to 15, which is divided like this. Understand? So 2 raised to 15 is my answer. So I am having 15. We know that if I am doing 2 raised to 20, it is 1 MB. So 20 bit address bus, right? So that means 15 lines are needed to represent 32 KB. Understand? So now what I need to do is, if this is 15, write down 15 times once. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All other will be 0. This is F. 3 times 1 and this is 0. Now this is my 20 bit number. this number represents 32 KB. Concentrate. Suppose I want 4 KB. Number for 4 KB. 2 raised to 2, 2 raised to 10, 2 raised to 12. Total 12 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. F, 0, 0. Understand? This is how you can get the number. So my number is 0, 7, F. This represents 32 KB, which I will replace over here. 0, 7. Now you can do subtraction. F minus F, 0, 0, 0. 7 plus 8, 15. And this is F. So F, 8, 000, H. This is the starting location of my room. Understand? Now I get the starting location of my RAM. I get the starting location of my room. Ending address automatically you can find out during your memory map creation. Fine, so it is not needed right now. This is clear? Step number 2. Find out the starting address of RAM and ROM. Clear? Yes. Okay. Now, step number 3. So, what is your step number 3? How many address lines are needed? Okay, we know that in 8086 20-bit address bus is available, A0 to A19, which will go to your memory, so you can access 1 MB of memory. Yes, same way here our chip size is 16 KB, and in this case the chip size is 32 KB. So if I want to access 16 KB of location, I require 2 raised to 4, 2 raised to 10, 2 raised to 14. Total 14 address lines are needed to access my 16 KB chip. Understand? Yes. Same way, if I want to access 32 KB of locations, I require 2 raised to 5, 2 raised to 10, 2 raised to 15. 15 different address lines are needed to access 32 KB of chip. Understand? Yes. So here, now we know that A0 and PHE bar, there are two signals which are used to access your odd bank and even bank. Remember, in memory banking, we have already studied A0 and PHE bar. These two are used to access your lower bank and higher bank. Yes? Yes. So we are not going to use these two. So other than that, if you want 14 address lines, you will use A1 to A14. Here you will use A1 to A15 because 15 lines are needed. This is your step 3. Understand? Step 1, how many chips will be needed? Step 2, what are the starting address? Concentrate over here. In finding starting address, you require total size of node. You are concentrating here. But when you find out how many address lines are needed, address will go into chip, not to total memory. It will go to chip. So here you are considering this part. Understand? So for 16 KB, 14 lines are needed. 32 KB, 15 lines are needed. Which lines will use? A1 onwards. We will not use A0 because A0 will be used for selection of even bank. Yes? Lower bank or even bank. Get it? If A0 is 0, we are accessing even bank. That was the logic in memory banking. Clear? 3 steps are clear? Okay. Now, just concentrate properly. Now you can stop. Okay, so now step number 4. Step number 1 is find out how many chips will be needed. Step number 2, what is the starting address of RAM and ROM. Third step is which address line will go into your memory. Yes, step number 4, you need to prepare a memory map. This is called your memory map. What is the starting address and ending address of each chip? How many chips are available total? 2 plus 4. Total 6 chips you need to assign, and for each chip you need to know the starting address, you need to know the ending address. Starting address of 20 bit, ending address of 20 bit. This is 8086. Yes? Okay. We know that it started with RAM. We have total 4 RAM. Yes. So RAM 1, then RAM 2, this one is odd bank, this one is, sorry, initially it will be even bank, this will be odd bank, even bank, odd bank. Total 4 chips. Understand? Clear? These are the 4 chips that you want to assign. Clear? Yes. Now we already know the starting address of RAM. What is the starting address? What is the starting address of RAM? Initial location 0, 0, 0, 0, 0, H. Yes. Simply write it down. 0. This is 0, 0, 0, 0, 0, 0. Understand? Yes. A12 to A17, A12 to sorry A15. We are simply write down single zero. You understand there are 4 zeros, binary zeros, right? It is 20-bit number. This is my 4-bit, second, third, fourth, and this is fifth. Understand? I just keep the A0 aside because we need to know that A0 is 0 when it is even bank, A0 is 1 when it is an odd bank. Clear? Yes? Okay, next. For this chip, RAM 1, even chip, I want us to find out the ending address. Now we know that this is even bank, so last address will be ended with 0. Yes? Now we need to remember step number 3. How many lines will go into your RAM? A1 to A1 to A15. There are 32 KB chip. So there are 15 lines needed. So A1 to A15 lines will go into your RAM chip. Yes? So that lines will get changed 00 to 111. That would be your last address. Understand? Of that particular chip. So I will change 111. This will become 1111. This will become 1111. This will all become P15. So it will become all 1111. Others line will not get changed. It will remain as it is. So it is again 0, 0, 0, 0. Understand what I have done? Yes. I have simply replaced lines A1 to A15 from 0 to 1. All others line will remain intact. A0 remains 0. I have changed A1 to A15. Understand? All others line will be as it is. So now my number is 0, F, 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 and this one is 8 ને 12 ને 14 એટલે E H. Your even bank always ended with E. It is not ended with F. F is odd number. E is even number. Understand? Yes. So this is my first chip, and I know the starting address of that chip, ending address of that chip. Clear? Yes. Now this is my even bank. 0, 2, 4, 6. This will be 1, 3, 5, 7. Yes. So now I need to find out the odd address of this chip. So we know that this will be started with +1. If this is 0, this will start with 1. So only this part will get changed. Odd bank and even bank માં ફરક શું આવે? ખાલી A0 bit નો આવે. બાકી બધું same આવે. So this everything will remain same for odd bank. Only this A0 bit will get changed. 1, 1. So what is my starting address over here? 0, 0, 0, 0, 1H. Yes? And where it will get ended? 0, F, F, F. Now E becomes F because of 1 and H. This is the ending address of my odd bank. This is my first two chip. Starting address, ending address. Clear? Yes? Understand? Easy? Now, my next, this is my RAM 1, odd bank, even bank, over. From the next location, what started? My next RAM, because I am having total 4 chip. Yes? So what I need to do is, simply it is ended over here. મારી પહેલી જે બંને બેંક છે તે ક્યાંથી ચાલુ થાય છે? અહીંયાથી ચાલુ થાય છે. પોતે ક્યાં છે અહીંયા યસ સો વેર માય નેક્સ્ટ બેંક સ્ટાર્ટેડ this plus 1 આ જ્યાં પણ એની પછીના નંબરની ચાલુ થાય it is as simple as that so it is over at location 0 f f f f plus 1 this is the starting address of my next RAM understand what is plus 1 f plus 1 10 10 10 10 1 so this is where my next chip will get started understand yes RAM 1 odd bank even bank total location done whatever is your last location plus 1 is your next starting location understand yes. So now I simply need to write down 1 0 0 0 0 h as we know that this is my even bank 0 0 write down 1 0 0 0 1 everything has to be 0 0 0 0 done again same concept how many lines will go into your RAM A1 to A15 so you need to change A1 to A15 everything else will remain as it is now let's start it here 0 0 0 1 this is A16 so it is remain as it is this will get changed F and this is not F here only A1 A2 and A3 will get changed 1 1 1 0 so the ending address is 1 F we know that even bank always end with E એટલે એ બી યાદ રહેવું જોઈએ તમે ત્યાં ચેક કરી શકો this is not even number or odd number so if you have done some mistake you can simply clarify understand yes this is your ending address of even chip now odd bank માં શું ફરક આવે only this will becomes 1 1 everything else will be same so 1 0 0 0 1 H simple only one will get changed and here 1 F F F F H khatam understand so my RAM will get ended and these are the locations for my RAM 2 this is the locations for RAM 1 understand even bank odd bank your RAM is sorted clear get it easy till now it is fine right now if you remember we have find the starting address of ROM now we need to attach two ROM chip also so here you are having a ROM same concept even bank odd bank we know the starting location of even bank what is the starting location F 80000 yes write it down that number 1111 is F 8 is 1 0 0 0 everything else will be 0 0 0 A0 will be 0 yes again same concept A0 is 0 even bank ma 0 jase odd bank ma 1 1 thai jase here how many lines will get changed it is ROM is of 32 kb sorry 16 kb line A1 to A14 will get changed remember A1 to A14 yes એના સિવાયનું બધું as it is 1 1 1 1 1 yes everything else will get changed 1 1 1 1 F F 1 1 1 understand now if I write down the binary number first is F second is also become F third is F fourth is F this is E H done simple niche everything is same only this becomes 1 1 because this is odd bank yes okay so F 8001 H F F F F F H and now we are set up because the last address should be this only then only your ROM will get ended so whatever you have started with is correct clear this is your memory map for 6 different chips now you know that if I want to access particular location in which chip I need to go clear yes okay here if I simply change 64 KB of memory you want to prepare out of 16 KB chip you need to make this for how many chip? 4 RAM chip and 4 ROM chip. So this table you need to make for 8 different chips. Understand? The concept will remain as it is. The only thing is you should know how to do this. This much thing is okay? Yes. Just keep this in your mind very clearly, because the next phase, if the sum will come for 10 marks, till now whatever we have done will come for 4 to 5 weeks. The next 5 marks will come now. This is actually the numbers that you know. Now you actually need to make a circuit. Now you need to apply your digital, electronics and COA concepts to make an actual circuit, how the physical circuit will look like. Clear? Now pause. We want to design it. So we want to make a circuit. We want to attach 1, 2, 3, 4, 5, 6. 4 RAM chip to ROM chip. Yes? Assume that these are RAM, this is ROM. This side odd bank, this side even bank. Simple. Now to attach it, you are having microprocessor which is connected with this decoder. We are going to use 3x8 decoder in all our examples, right? Because you can do any sort of interfacing using 3x8 decoder. What decoder do? If I give 3 inputs, if all are 0, 0, 0, y0 will become 0, everything else will be 1. Understand? If I give 1, 1, 1, y7 will be 0, everything else will be 1. Understand? Only one output will get changed, all others will remain same. This is what a decoder do. Yes? These are concept of D. These are the chip. Before jumping to do actual interfacing, you should know the basic thing. This is your E1 bank. So here your D0 to D7 data line will get joined, 8-bit data bus. Here we know that this is my higher bank. D8 to D15 data lines will get joined. 8086 is 16-bit microprocessor. You are having 16-bit data bus. These are very likely data. Clear? Yes. These are my RAM. So here A1 to A15 address line will go. Same line will go over here. Same will go here. Same will go here. We have already found it out. Yes. You need to make sure that address bus, data bus, control bus will be there in each chip. Clear? Data bus is clear. Address bus is clear. Here it is A1 to A14. It will go here. It will go here. Understand? Data bus clear. Address bus clear. Next is control bus. Which are control bus? Memory read, write. So here memory read, write. Memory read, write. Memory read, write. Memory read, write. Only memory read, memory read. Simple? Yes. Because these are wrong. No write. Only read. Complete? These signals are wrong. Now we want to find out something so that we can select this chip. What we actually want to do is, as far as 8086 concerned, આ બે ચિપ સિલેક્ટ કરવી જોઈએ. આ બે માંથી મારે ખાલી આને જ કરવી છે તો પણ થવી જોઈએ. પણ એવું નહીં થવું જોઈએ કે આ પણ સિલેક્ટ થાય ને આ પણ સિલેક્ટ થાય. Understand? This is different bank. This is different bank. This is different bank. Understand? So at any given point of time, this should get selected, or this, or this. અને આ બેમાંથી મારે ખાલી આને કરવી હોય તો થવી જોઈએ. This is what my target is. Yes. If you want to, like if you understand memory banking clearly, you are having odd bank, even bank. You want to take only 8-bit data from odd bank, select it, fetch it. If you want to select 8-bit data from even bank, select it, fetch it. If you want 16-bit data, select both the banks, fetch it. But at any given point of time, only one bank will get selected. Understand? If the two banks will get selected, that is not possible. Your address is overlapping, right? Yes. This much stuff is okay. Ana CY. Okay. We have A0 to select this. We have BHE bar to select this. So give that signal also. A0 BHE bar to select this. A0 BHE bar. This one thing is okay. To select odd bank, you require BHE bar. To select even bank, you require A0. Okay? When you can say that your interfacing is over, when all A0 to A19 lines are available in each chip. કોઈ પણ ચિપમાં એડ્રેસ છે તે કેટલા બીટનું છે 20 બીટનું 20 બીટનું એડ્રેસ આપવા માટે તમને 20 લાઈન જોઈએ એટલે બધી ચિપમાં 20 લાઈન જવી જોઈએ સમજ પડી યસ જો 20 લાઈન નથી જતી તમે યુટિલાઇઝ નથી કરી એનો મતલબ તમારું ઇન્ટરફેસિંગ હજુ પૂરું નથી ક્લિયર યસ ઓકે સો this much thing is over now I want to select this or this chip હવે આમાંથી કઈ બેંક સિલેક્ટ થશે એના માટે શું કરવાનું for that concentrate you need to always try to find out something from the left hand side of the memory bank always ક્યારે શોધવાનો from the most left hand side from the memory bank find out three lines which are consecutive three lines because three lines are the input your 3 to 8 decoder you need to find out three lines in such a way that they will give you different combination for this bank and this bank RAM 1 RAM 2 and ROM okay this is my RAM 1 this is my RAM 2 this is my ROM you need to find out three such lines let's start with A15 is 0 1 અહીંયા ઝડપ છે so it is not same સમજ પડે 0 1 0 1 here it is 1 1 now if you concentrate on 16 17 18 0 0 0 0 0 0 1 1 1 1 1 1 0 0 1 0 0 1 so here it is 0 0 0 here it is 0 0 1 here it is 1 1 1 so for all three banks it will give you different answers that is what you want understand yes समझ पड़ा क्या नहीं पड़ती you want to find out what you want to find out this is again 0 0 0 so 0 0 0 is totally same for RAM 1 0 0 1 is same for RAM 2 and 1 1 1 will remain same for ROM understand so if I choose this three line this will give me three different options easily yes so here what I will do is I will choose A 18 17 and 16 now concentrate if all three are 0 0 0 then your Y0 will get selected it will get 0 yes and if that will get selected you need to select which part RAM 1 so here it is my RAM 1 I just need to select A0 and this line this will get OR and go to my now why OR is used that is your basic digital electronic concept if A0 is 0 and this line is also 0 you will want to select this line understand if BH bar is 0 and Y0 is 0 and it is OR you want to select this line and if A0 is 0 BH bar is 0 and even Y0 is 0 you want to select both these two that's why OR gate is used understand OR gate is the only gate which will give you 0 when your both inputs are 0 and it will not give you 0 other than that if it is 0 1 1 1 0 1 1 1 1 understand so we can't use AND gate because AND gate will give you 0 0 on 0 but also give you 0 1 0 આપણે શું જોઈએ છે મને 0 આઉટપુટ મળવું જોઈએ પણ ક્યારે જ્યારે બંને ઇનપુટ 0 હોય ત્યારે so that is only possible using OR gate so that's why this OR gate is needed now here is the usage of your OR gate understand yes now Y16 17 and 18 if it is 0 0 1 Y1 will get selected and if it is Y1 you want to select second again use OR gate give it over here this chip will get selected if it is 1 1 1 RAM will be selected ROM will be selected over here OR gate give it to your both the chips your diagram is done understand no one second it is not over yet as I said જ્યાં સુધી A0 થી A19 સુધીની બધી લાઈન બધી ચિપમાં ના જાય ત્યાં સુધી તમારો ડાયાગ્રામ પૂરો થયો નથી A0 to A15 is done yes in RAM 16 17 18 is used over here so they are also done what is about A19 it is not yet utilized so A19 will come over here if it is 0 you need to select this Understand? Again, A19 will come. If it is 0, you need to select this. Again OR gate. If A19 is 1, so if A19 is 1, you first need to make it 0. So AND gate, sorry, NOR gate, make it OR. Now A19 is also a catch. Yes? हजू एक बाकी है. If you see the ROM carefully, ROM is only taking A1 to A14. 15 is remaining. What is A15 in that case? A15 is also 111. So again A15 NOR gate, make it OR go here or go here. समझ पड़ी? Now your full circuit is over. This will carry 5 marks. Interfacing. Understand? Yes. Let's. So what is your task to do interfacing? You need to find out 3 lines in such a way that 3 lines will give you different combination for different chip. Yes, by chance your memory map is in such a way that you don't get it. તમને એવું મળતું જ નથી કે બધા માટે અલગ અલગ આપે. At least 2 chip માટે તો સેમ આપે છે. તમને એવું મળે છે. Then what to do? Concentrate. So this is my 3 cross K decoder. These are my suppose chip, 6 chip, and we don't want to find out anything. We simply go with A19, 18, 17. Then concentrate. So here I am using A19, A18, A17. Okay, now concentrate. If A19, 18 and 17 all are 0, 0, 0, that means Y0 is get selected. What you need to do? 0, 0, 0, 0, 0, 0, 0, 0, 0. So if Y0 is 0, it will select RAM1 also, it will select. Understand? So if it is Y0, this line will go here also, the same line will go here also. Understand? And here it is 1, 1, 1. So if it is Y7, it will go here. Done? Yes. But now problem is, because of these 3 lines, this both bank will get selected. We already decided that there should be a line, so that at a time only one bank should get selected, not both. Yes? એટલે તમારે હવે શું કરવાનું? આગળ જઈને એવી એક લાઈન શોધવાની જે RAM 1 માં અલગ હોય અને RAM 2 માં અલગ હોય. કઈ લાઈન અલગ છે? This is 0, 0, 1, 1. So A16 is the line which will separate both of them. Yes? So what I will do? A16. If it is 0, it will go here, or with this and go over here. Done? But same A0 will come over here, apply NOR gate. Now here, here, and your program is done. Now because of A16, this both will get different. Understand? So still this diagram is also correct. There is no mistake in it. It will work. So if you are not able to find out something common, you can simply go with 19, 18, 17. Understand? Yes. Which gate we are using? OR gate. And if your input is 1, to make it 0, we are using NOR. Just keep in mind. Okay? Now there is one more option, but it is a little bit difficult. So just concentrate. In case you are directly using A17, 16 and 15. 17, 16 and 15. So 0, 0, 0, 0, 0, 1, 0. Okay. So for Y0 also and for Y1 also, your same bank will get selected. Same way, this is 0, 1, 0, 0, 1, 0, 0, 1, 1. 0, 1, 0, 0, 1, 1. So what is 0, 1, 0, 2. So Y2. And 0, 1, 1 is Y3. So in these both the cases, your RAM2 will get selected. Understand? Yes. The only thing is, when these both inputs are same, you want to select this. So in this case, you need to use AND gate. Now why you need to use AND gate? For that you need to understand the concept of basic AND, because you want that when the both are 0, at that time only, if આપણા OR gate ક્યારે વાપરતા હતા? We are using OR gate where we want that both inputs should be 0 every time. Compulsorily both inputs should be 0. In this case, if it is y0, still you want to select this. If it is y1, still you want to select this. So if anyone is 0, it should get selected. So in that case, 0 0 0 0 1 0 1 0 0 AND gate. So that's why we are using AND gate. Understand? So if there are more than one output comes, you need to use AND gate. Normally you don't need to utilize it, but just for your knowledge you should know this. Like chhalle kahin पण આવે, you can do interfacing, but you should know the tricks. Clear? If there are no common lines, simply use 19, 18, 17 and divide them with new lines using OR operation. Yes? That is the final solution, which is also possible. Clear? So this is your memory interfacing. If you want to learn the same thing properly in detail, you can refer Bharat Acharya's video on the same topic. He has given the same example, so you can get it properly also, right? Plus the same video is also available, so you can watch it with a slow pace and you can try it yourself. Done? Thank you.